this vast amount of space junk poses a few problems. The most obvious one being that one day these objects will fall back down to Earth. Currently, no one has reported being injured from falling space debris. This is due to the fact that most of the Earth is covered by the ocean, and all objects smaller than 10 centimeters will burn up in the atmosphere as they're coming back down. But just because no one has been hurt yet, does not mean that no one will be. Another problem that you may not have considered is the damage the debris do to functional spacecraft. This includes our satellites for communication and weather. Even though most of the debris is small, it is moving at 56,000 kilometers per hour. In fact, the International Space Station regularly needs to take evasive maneuvers to avoid large. Some ways that are being researched and used today to reduce the production of new debris and to mitigate the effects of current debris are the assurance that a satellite will remain in orbit no more than 25 years, the use of dust and slag limiting propellant, the attachment of cover caps and pyrotechnic devices, the use of ductile materials as paints to minimize blistering and flaking, making the spacecraft as small as possible, not planning missions during expected meteor streams, multi-walled structures, and voluntary legislation stating that the country of origin is liable for the equipment that they launch. While these approaches using robotics. So one concept is to use a high power laser to push debris into a higher orbit, where it poses less of a risk. These higher than normal orbits are called graveyard orbits. There has been a study on this called Project Orion done in 1966 by NASA in partnership with the United States Air Force. However, the first problem with this solution is that it is costly. One laser would cost $800,000 for the laser alone, and then you have to add on an additional millions of dollars incurred by the telescope and its operation system. One laser would only be able to engage. A further development of this idea is the SlingSat. It is designed by two engineers at Texas A&M University. The idea is to create a satellite that can send multiple pieces into the Earth's atmosphere to be incinerated, as opposed to the Swiss's solution, where one satellite returns to the atmosphere with only one piece of debris. The reason that this couldn't be done before was that the energy required to move and intercept pieces of debris is so huge based on the scale of the distance between the debris. The SlingSat solves this problem by using the momentum of debris to propel it from piece to piece. The initial collision provides some energy to move to the next piece. Additional energy is provided upon the ejection of the piece towards the Earth's atmosphere, based on the conservation of momentum. However, right now this concept has only been simulated. Also, the mechanics are not fully finalized, or are there any announcements of it being manufactured as far as I'm aware. I believe that this type of innovation is extremely important and needs to be further developed, since the human race will have to deal with the problem of ever-decreasing debris if we want to protect our civilians on Earth and to protect our astronauts who are leading our exploration into space. To conclude, space debris is a problem for today that is only predicted to grow in the future. There are strategies already being implemented to limit the growth of the problem, such as the better choice of materials to limit debris, smart orbit planning to avoid debris, and structural engineering to protect spacecraft from debris. However, the best way to physically remove debris is still being studied, and there are no clear answers to this problem. Although there are many promising ideas in the field of robotics and of lasers, and other ideas not discussed in this presentation. Additional complications of these ideas bearing consideration, such as the cost efficiency and the political acceptance of these ideas, have not been resolved, so good engineering innovations are needed to solve our problem of growing space debris.